Okay, in this lecture, brief lecture, I will cover what we expect from your research proposal and delve into some examples. First, this is a project-oriented course. 40% of the grade is determined based on the project. I know you're not here for the grades, but this is an exciting potential for you to do a great research project. This is your chance to explore in depth a computer architecture topic that interests you. You may be doing computer architecture for your life afterwards, or this will be the last computer architecture course you may have taken, but you can actually do a big contribution based on this research project. And perhaps even publish your innovation at a top computer architecture conference, and I would ask you to strive for this. And this may sound like a tough thing to do, but there have been many papers that are published as a result of 740 previously at top conferences like ISCA, Micro, HPC, and SIGCOMM, as well as workshops too. But what is really important is for you to start thinking about your project topic and project proposal, as well as project group from now. Right now, actually, you can start thinking, and I'll give you some potential topics to ponder about. Please interact with me and the TAs. Read the project topics handout well and do your own research. Dig out information. Projects will be conducted in groups of 2 or 3 students, and we will finalize this later. And you can certainly propose other potential possibilities to me, but this will be the norm. It's very important that every single one of you, every individual, contributes equally to the project. And equally, I mean equally. So at the end of the project, we will ask you as an individual to evaluate other individuals, your partners, in terms of their contributions. And I would like everyone to say everybody contributed equally to the project. And if there are issues during the semester, please let us know early. Please let us know so that we can actually potentially help you with the issues that you're facing during your project and with your group. And hopefully there won't be issues. The proposal is the first important step in your project. This is due within 3 weeks of the first recitation session. And let me delve into the details of the project a little bit. The goal of the project is to develop insight. The goal of any project, hopefully, is to develop insight. And the goal of a research project is actually to develop new insight. Now, in this course, I'm open to both research projects as well as evaluation/implementation projects. You can do either one. How do you develop new insights? Basically, you solve a new problem in a new way, or you evaluate and analyze existing systems and existing ideas and find something new in them, find something insightful in them. And I'm open to both types of projects. There are 2 types, type 1 and type 2 as I classify them, and they're potential types that are within this continuum. The first type, you will develop new ideas to solve an important problem and rigorously evaluate the benefits and limitations of the ideas. So that's the first type. You could choose to do a project like this. The second type is different, but leads to insight again. You derive insight from rigorous analysis and understanding of existing systems or previously proposed ideas. Basically, evaluate some hypotheses on existing systems or some hypotheses related to previously proposed ideas, and based on your evaluations and analyses and characterization and modeling, you propose potential new solutions based on this new insight. Again, these solutions do not need to be evaluated rigorously, but these are solution directions that you propose. Basically, this is the second type of project. This is more of an experimental research project. And I'm open to both kinds of projects. I'm open to more hardware-oriented projects, more hardware-software cooperative projects, as well as more software-oriented projects, as long as there's an architecture component in it. For example, the problem that you're trying to solve could be the problem of memory interference. When multiple cores share main memory, one of them gets unfair service. One of them stars, for example. Then, how do you solve this problem could be a broader topic of your research project. And a concrete idea could solve this problem in software, in hardware, or in a hardware-software cooperative manner. And I'm actually open to all potential ideas. For example, you could devise operating system level thread scheduling techniques that try to solve this problem by scheduling threads that do not destroy each other's performance in main memory together to share main memory. And by not scheduling threads that destroy each other's performance together at the same time. Or another potential solution could be throttling some threads. Operating system can apply dynamic voltage and frequency scaling to cores that are potentially more aggressive to the other cores. Or maybe the operating system can figure out somehow when the memory is loaded, it's becoming oversubscribed in terms of bandwidth, and throttle some cores to maximize performance to potentially improve quality of service in the system. So these are different solutions that could potentially be research projects, and where you can actually propose software solutions and evaluate them on real systems as well. The key important thing is the problem and the ideas need to be concrete, and this concreteness will lead to a strong and clear research project that you can conduct smoothly within the course of 2 or 3 months. The problem and goals need to be very clear also. It's very important to articulate these very clearly. I've given you a couple of examples, for example, in terms of the problem, the main memory interference problem. It needs to be clearly defined, and also the solutions need to be clearly defined. Let's take a look at what do we expect from the research proposal. I'll give you an outline of the research proposal of the main components, and I'll give you an example of type 1. Type 2 will be relatively similar, and I'll give you that example as well. The first step in the research proposal is to formulate the problem. What is the problem you're trying to solve? Define it very clearly, articulate it, explain why it's important. And one way of explaining why it's important is showing the benefits if you eliminated that problem. For example, one problem in microprocessor design is you get misses to main memory. You get cache misses. Why is this problem important? Well, if you eliminate these cache misses, our evaluations show that you get 300% speed up. Well, it's an important bottleneck then in the systems. So showing that ideal result could be a good motivating factor in the problem. But you don't always, not all problems, not all problems have, you can demonstrate with an ideal solution or what if kind of experiment. So sometimes you will need to reason about why that's an important problem. But this is the first step, defining the problem. The second step is novelty. Why has previous research not solved this problem? Or literature survey, put another way. What are the shortcomings of previous research that tried to solve this problem? It's unlikely that there will be a problem that is not tackled by any previous research. And if you come up with such a problem, I'd be very interested in talking to you about it. But there will very likely be some previous research that looked at some problem or similar problem, and we'd like you to describe and cite all relevant works that you know of and describe why these works are inadequate to solve the problem. What are the advantages and disadvantages of these previous works? And this will be your literature survey. The third part of the proposal is the idea. This is a type 1 proposal. It's an idea type of proposal, idea type of project. What is your initial idea and insight on solving the problem? What new solution are you proposing to the problem? Why does it make sense? How does it, or how could it solve the problem better? For example, one idea that you may have on one problem, let's say the problem is we're refreshing DRAM too much. There are too many refresh operations that are required in a large capacity memory system. One idea you might have is there's a lot of variability in the retention times of these DRAM rows that you have. And maybe the idea you have is we're going to find out how much variability there is and basically remove from the operating system's consideration those memory rows that have very low retention time, such that the operating system never maps pages to those rows, so that you don't need to refresh memory as frequently. That could be the idea, and that's a very concrete idea. It has been proposed before, there's that problem, but if you're doing an evaluation project, it's certainly fine to propose this and evaluate it on potentially a real system and show the benefits of it. And this would be a great project if you actually pull it off and show experimental results and show them how much power you can save, how much performance you can gain. So that idea is important. In this case, I guess I had the benefit of hindsight, but this hindsight appeared based on the research we've done and others have done also. The fourth part of the research proposal is a hypothesis. What is the main hypothesis you will test? Once you have an idea, it's good to have a hypothesis. We hypothesize that this idea will improve power consumption or reduce power consumption by 50%. Like that could be a good hypothesis on some workloads, of course. That's a very concrete hypothesis. It's good to have concrete hypotheses as well. And finally, well, I guess not finally, but before the finally, methodology is the proposal. How will you actually test this hypothesis? Describe what model you're going to use. Are you going to use a simulator? Are you going to do the evaluation on a real system? What initial experiments will you do to test the hypotheses? And what are the plan for the experiments going into the future? And again, I'm very open to different methodologies. The solution methodology depends on the idea. The evaluation methodology certainly depends on the idea that you have to solve the problem. For example, if your idea is to reduce memory interference by throttling cores at the operating system level, then an experimental evaluation on a real system with a real operating system and a real multi-core system is called for. And you can certainly propose that methodology and describe what kind of initial experiments you will do, what kind of systems you're going to examine, what kind of workloads you're going to examine. You can certainly propose a hardware-software cooperative methodology, in which case you modify the hardware and show the benefits on a simulator. This is also fine. You could potentially implement, for example, one problem you may solve is computation is a bottleneck in the processing of genome sequence analysis workloads. That could be the problem that you're going to solve. And you may decide to accelerate these workloads using an FPGA or a GPU infrastructure. And then your methodology would be to port some of these workloads to the FPGA and GPU and to accelerate them and to actually show the benefits of acceleration that you get. So your methodology will definitely depend on your idea, and I'm very open to different methodologies, including theoretical analyses of computer systems. And as long as you can convince me that you have a good plan, I'd be happy to consider such projects. And finally, the plan. Basically, describe the steps you will take. What will you accomplish during the course of the semester, at the end of the semester? And we'll have some milestones during the course of the semester. It may not be 1, 2, or 3. It may be 2 milestones or maybe 1 milestone. But we're going to tell you how many we will have. And we'll expect you to provide what is your goal. What do you intend to accomplish by that time and by the end of the semester? And we'd like you to specify your goals as 100% goal, for example. This is the goal that you would achieve if everything goes well and right. 75% goal. This is the goal that you will achieve if there are some issues, for example. Like you're delayed for some reason, your experimental infrastructure didn't work as fast as it could. And what are the goals you will achieve if everything goes really well? What is a moonshot goal? Those are important to specify in your plan. And all research projects can be, and actually I would posit that should be described in this fashion, and we'll expect to see these components in your research project. This could be actually, all of these components could be different sections in your research project. Let's take a look at a type 2 proposed outline very quickly. It's very similar except with some minor differences. First, the problem. The problem always comes first. You can actually apply this outline to pretty much everything in life, I would argue. You could, if you're examining some concept, you start with the problem. What is the problem, right? So what is the problem? What is the phenomenon you're trying to evaluate in this case? It's a type 2 proposal. Remember, it's more of an experimental evaluation or maybe theoretical evaluation of an existing idea or of an existing system. Again, you need to define this very clearly. Explain why it's important. What is the problem related to? Novelty, how has previous research evaluated this? There must have been potentially some evaluation papers that looked at the same phenomenon. What are its shortcomings? Again, this is your literature survey. An evaluation method is the third one. How will you evaluate the phenomenon and the idea? What experimental infrastructure will you design? How does this experimental infrastructure represent the state of the art? For example, you may be evaluating an idea that was proposed by someone else. Then, how does your experimental infrastructure resemble that? Or maybe there are some problems in the experimental infrastructure that others have used to evaluate the idea, and maybe you're going to do a much better, much more comprehensive evaluation of the idea on a different experimental infrastructure and with different parameters. Then it's good to state that as well. How would that experimental infrastructure enable you to reliably evaluate the phenomenon idea? So why is this experimental evaluation method valid? So that's important to state as well. Then we go into the hypotheses. What hypotheses you will test with your evaluation method? And then we go into the methodology. What are your plans for evaluation? What experiments will you run? How will you test? How will you do the data analyses? So one example that I would like to give, again, is from the problem of memory interference. When you have multiple cores, they're accessing memory, they interfere with each other. And maybe you would like to evaluate the effect of this on modern data-intensive application. Maybe you would like to take a database and figure out the effects of memory interference between threads on a database running on this latest and greatest 16-core multi-core system from one company or the other, or maybe a 100-core multi-core system from Tylera. You install that database and you figure out what kind of interference patterns exist in that database on a real system, and you report the effects of memory interference in caches, interconnects, and main memory between these different threads. And you analyze the effect on quality of service, effect on power consumption, and effect on overall system performance. And in this case, your novelty will be no one has evaluated such a large-scale application on a multi-core system and evaluate the effects of different components, caches, interconnects, and main memory. This is an ambitious project, but it's a novel project. It's an evaluation project, right? It's an experimental project. It's not a new idea project. You can propose new ideas after you do this experimental evaluation. Then you talk about the experimental evaluation method. What is your platform? What is the kind of platform you're going to test this, you're going to do this evaluation on? And what kind of experimental infrastructure will you design? How would that experimental infrastructure enable you to reliably evaluate the idea? And then you should describe clear experiments as to plans for evaluation. Maybe you can say, for example, you will examine the effect of different kinds of threads when they interfere with each other. Perhaps you can characterize these different threads in terms of their behavior and show how much interference happens, how much slowdown these different threads incur based on their characteristics, based on the program based on the performance counter data that you have for these threads. And you can define different experiments to actually evaluate the effects of interference. So the potential possibilities are many. As long as you clearly define all of these, you can get a good research proposal even with an experimental research project. And I'm very open to all kinds of research projects. If you would like to do an experimental evaluation of a real system and generate insight based on that, I'm very open to that, and we'll provide some papers. If you would like to do that, please ask me for some papers as well, and we'll provide some papers in the project topics handout as well. So finally, the last part is the plan, just like we've discussed for the type 1 research proposal. And again, all research projects can be and should be described in this fashion. So before we conclude, I'd like to talk about Heilmeier's catechism, because some of the research proposal that I asked for is actually what's employed in real life in many cases. And it's not only for research, I believe, it's for every problem in the world. You can define solutions this way, solutions to research this way. So what is Heilmeier catechism? This is basically a set of questions George Heilmeier used to ask, or suggested everyone to ask, to people who are proposing a research idea, or to people who are proposing to devise a product for a particular market. Basically, who is George Heilmeier? George Heilmeier was actually the inventor of liquid crystal displays, the LCDs that you use today. And he actually implemented a relatively less power efficient version of it, and others have improved upon the design and made it much more power efficient over time, but he's the original inventor. He also was the director of DARPA, which is the Defense Advanced Research Projects Agency in the United States, which used to be the major funding source in the 70s and 80s to academia, as well as, I believe, industry and national labs. And when he became the director, he wanted to institute some practices as to how funding should happen to different researchers in the United States. And he came up with a set of questions, now known as Heilmeier's catechism, that a person who proposes to do research on something should answer, or a person who proposes to design a product related to something, to do something, should answer. And then based on this, he would say, yes, I will fund your project, or no, I won't fund your project. And this Heilmeier catechism is actually very popular. It's used in not only funding decisions, but also decisions made by venture capitalists to fund a company. And you could use it, and we're going to use something similar for your research proposals, for example. In this case, you don't need to worry about funding. Basically, if you like your research proposal, if it's clear, articulate, solving a good problem, and ... then you will get to do the research, which is great, and hopefully solve the problem really well. But basically, my point is, Heilmeier's catechism is which is employed widespread today in many institutions, is very similar to what I've described as your research proposal. He asks, what are you trying to do? Articulate your objectives using absolutely no jargon. And no jargon is a good thing, actually. if you can convince many people in the world without any jargon, that's better than using jargon and not convincing anyone. How is it done today, and what are the limits of current practice? This is basically your literature survey, right? What's new in your approach, and why do you think it will be successful? What's the novelty? Who cares? Are you solving a problem that matters, or are you solving a problem that doesn't matter? Now you need to be careful over here. The problem is important. Many problems can be important if they're described in a given context. So you may think that a problem is not important, but if you describe it in a context, in a different context, it may become important. For example, you may in 1990s, people were designing processors that had increasingly deeper pipelines. At that point, people didn't care about power consumption. At that point in time, you may come up with a really good power savings technique. Let's say pipeline gating. The idea is, if you think you're on the wrong path, if you're executing instructions speculatively and the processor has gone on the wrong path, gate the pipeline. Now this is a great idea today in a power limited environment. It may not have been as interesting of an idea in 1990 because power was not a big problem. Power consumption was not a big problem. But if people actually thought about this, they thought about the problem and the solution in a different context, they could think that, oh, there could be someone who cares. This problem could be important in this context where power is limited. And even in 1990s, there were contexts where power is limited. So it's important to tailor that who cares, the answer to that who cares question to the context itself. In a power limited environment, this idea may be useful. In a non-power limited environment, who cares about this idea, right? So it's important to describe the conditions under which your idea is important. And in many cases, if there is a good idea, it's probably useful in some context. And if there is a problem, it's probably a problem in some context. You just need to find that context. If you're successful, what difference will it make? This is important. You don't need to answer this obviously in your research proposal, but this should be implicit. What are the risks and the payoffs? Again, we don't want you to answer this necessarily. How much will it cost? Again, we're not funding you, but these are some of the real questions people ask. How long will it take? Well, in this case, you have limited time. It should take 2 or 3 months. And that's why you should tailor your project such that it can be sold within 2 or 3 months. But it's okay to be ambitious in your research proposal. I would encourage you to be ambitious. It's better to be ambitious and fail, not fail necessarily, but get to maybe 75% of that ambition, than propose something that you can do within a week and accomplish that. And I will actually discourage you from doing projects that are that do not have enough meat in them. And finally, what are the midterm and final exams to check for success? So these are the questions called Heilmeier catechism. And this is one version. There's another version which is more concise, which is pretty simple actually. What is the problem? Why is it hard? Hard problems are important, good to solve. How is it solved today? What is the new technical idea? Why can we succeed now? What has changed? What is the impact of successful? And these are good questions to ask to anyone who's proposing an idea to you in general. Okay, there are a bunch of supplementary readings I have on research, writing, and reviews. One of them you're all already doing as part of your first review set, Hamming's You and Your Research paper. This is good for a lot of things in life in addition to doing research. Levin and Redell's How to Write a Good Systems paper would be good. Eventually you will write a research paper at the very end, which and I would like that paper to be of quality of submission to a reasonable conference in computer architecture. I know this is a high bar, but it's good to shoot for that bar, and other people have actually achieved that bar earlier. And the task of the referee will help you evaluate different ideas, different papers. Simon Peyton Jones' How to Write a Great Research Paper is a very good starter reading, and it's actually a talk. And finally, there's an updated bibliography on how to write a computer systems research paper. You can take a look at that as well. And I'd be happy to take any questions from you. Please feel free to email me regarding this, and email the entire research team. And there's a bunch of other places where you can get project topics and ideas from. Your project topics handout is the most important one. And your assigned readings are also very important. For example, the first assigned reading for September 9, the memory scaling paper that I've written, describes a lot of different potential research directions in memory and potential research ideas in memory as well. So you could actually read that and come up with a research proposal based on that if you're excited about it. There are concrete research topics in that direction in that paper. And there are a bunch of papers where you can generate concrete research directions from. And recent conference proceedings are always good to look at. ISCA, Micro, HPC, ASPLOS, and other systems conferences. And you can go through the abstracts and titles as well as sessions, and you can read them. And you can read the papers that attract your interest. And you can actually find some research topics to investigate based on your readings. And these usually represent the cutting edge research in the computer architecture field. So you can find a lot of attractive research topics by skimming through the conference proceedings, as well as going through the assigned readings some of which will be coming from those conference proceedings. For example, in the assigned reading that I have up here on the memory scaling paper, I discuss a lot of research in recent conference that appeared in recent conference in 2012, 2013, and a little bit earlier as well on memory scaling. So this could give you a good idea of what kind of research has been done in the field and what you can improve upon. Okay, that's all I have on research proposal and topics. I wish you a good 2 or 3 months of doing a great project, and hopefully you'll be successful. But the first step is coming up with a very clear and articulate research proposal.